We're studying IGCSE physics and we're starting electricity too. Diana, recap, what did we do in the last class? Diana. Luna, can you hear me?
Yes, sir, I can hear you.
All right, recap, what did we do in the last class?
In the last class, we learned about the objective, electricity, charge, voltage, and in this, and then we also learned about the insulators and conductors. And for today's class, we'll be learning about current and resistance.
All right, so we looked at charge, okay, and we looked at
electric charge and its rules.
All right, electric charge and its rules. Perfect. Now, one thing
we'll
recap that again. Perfect. So we also looked at induced charges and charge. Now, today our goal is to start current and voltage. We'll also look at a few more things. Just to recap, let's just start again. Now, charge, I'll tell you what charge means first. We won't look at induction of charge right now, but we look at charge. What is charge? Charge is a property of matter in a electric field. So, like mass, what is mass? Let's compare this with mass. Start writing. Now, mass is a property of matter in a gravitational field. Right? If you are in gravity, you will have a mass, and that is why you have a weight. So let's say if my weight is about let's say the average weight of a person, of average for everyone, in physics, we'll have to take the weight as 60 kg. So if they ask you what is the weight of someone, you should give 60, don't give 30, don't give 100. That's not the average, right? Those are possible, but that's not the average though. So we'll take average. The average person is 60 kg. Where does that mass come from? That is basically a property of someone in a gravitational field. You can feel that mass and that weight because of the gravitational field. In the same way, we have something called charge. Charge is only in an electric field. Well, charge is because of an electric field. All right. So let's look at these electric fields right here. Just a second. Okay, I'm mentioning electric field a lot. What is electric field? You may ask, what is electric field? Electric field is a region where charge experiences a force. In the same way, gravitational field is a place where mass experiences a force. Now, Najla, can you hear me?
Yes, sir.
Now, have you ever, let's say, when you walk on Earth, do you feel gravity?
Yeah.
Yeah, everyone does, right? That's obviously true. Everyone does it, right? What a stupid question. But it's not actually stupid. Why? Because let's say if you go into space, there is no gravity there.
Yeah.
Then, well, there's no gravity there. So what does that mean? Well, that means that you won't experience the force of gravity there because there is no gravity. So wherever you have a gravity, since everyone has a mass, everyone will experience a force in a gravitational field if there is one, like Earth, like Moon. So we'll see this. Okay, so gravitational field is, don't write the gravitational part, just write the electric field part. I'm just trying to compare it with what we already know. So you should think of electric field as something as common as gravity. Electric field is the same as gravity. It's everywhere, mostly, right? Mostly. Now, so charge is a property of matter in electric fields. Okay, fine. We now look at electric field patterns. What are electric field patterns? Well, since if I make a positive charge, Now we know that charges are of two types, either positive or negative. Navada, can you tell me, where do we get negative charge from?
We can get it from the earth.
No, from electrons. Is that clear? From
Yes.
electrons. Or we get the negative charge when we have let's say too many electrons. And we get positive charge when we have too few electrons. Is that clear? Now, Safa, read these two out loud. For positive charge.
For positive charge, too few electrons. For negative, too many electrons.
Right. So if you have too much negative, you become negative. If you have too less negative, you are positive. That's good, right? That's how life is. That's how you should be. But in physics, it's much more than that because we're doing electric field patterns, right? So let's start from here. So we know what charge is now, but we should also know what are electric field patterns. So it's always, let's write it here. Electric field pattern is always from positive to negative. Rana, read this out loud.
Electric field practice always from plus IV to minus CE.
Right? VE is basically positive. The tiv basically positive, which means always from positive to
Yeah.
negative. Right? All right.
Yes.
Now, next thing is, what does that mean? Well, if I have a positive charge like this, and this is plus, the electric field pattern will look something like, well, first we'll make some lines. So we'll make a straight line, we make a vertical line, then we'll make a horizontal line. Everyone should be drawing this, but wait a second, not right now. Okay, draw lines like this. Then we know that inside the particle, we don't really have electric field. It's only outside the particle, not inside charge. Let's remove all of this. And this is our electric field. Now these are also radial. For unit positive charge, electric field is field lines. These are called field lines, electric field lines. Now the properties are that they are first straight and they are radial. Fine, perfect. So they are radial. What is the meaning of radial? Well, it goes out in circles.
Do we write the parts from unit positive charge or we draw and write?
First you draw and then write beside it. Or write this first, then draw. Okay. Now there's a direction which we need. Direction is always from positive outwards, so positive to something. So it's going out of positive, never towards positive, right? It's from positive. That just finishes what we did in the last class.
So
now from this, we'll also have, yeah.
I have to write the points first, then draw the diagram.
Yes.
Okay.
Now the heading should be electric field patterns, and write this as the first one. So for positive charge, that is the first one. The word unit positive is important because it's a unit positive charge, which means it has +1. It's not +2. It's always just 1. And the main thing is this, that it's always from positive to negative. That is the main thing. That is why I've put this symbol right here, which you should also put in your notebook. Now next which we have is, it's called unit negative charge. What about that? We don't just have positive charge, we have negative charge as well. For negative charge, everything is same except the direction changes. It's always two negative, or towards the negative charge. It's not towards away from negative, it's towards negative. Positive to negative. So it will be towards. Finish writing this and tell me when you're done. Safa, can you hear me?
Yes, sir.
So just a second. Add one more. Safa, are you writing?
Yes, sir, I'm writing.
If you have any questions, ask me. Now this is outwards. Let's just say direction is outwards. But for this one, the direction is inwards. Finish writing, tell me when you're done. We have other as well, not just these. That's one, this is two. We have third type as well. Type 3. The third type is going to be this one. If I have two plates. Now let's say I have one positive plate and negative plate. The field lines are always going to be straight. And what we realize is that the direction is always positive to negative. Now, before you make this one, actually, I want to show you something else. What if I have both positive charge and negative charge? Close to each other. What will the field lines look then?
They will
How
repel,
will
and if two negatives,
they
they
will?
will repel. Two positives
But
will attract.
the
The positive
opposite
and negative,
attract
yeah,
and opposite
the
attract.
same will repel.
Same repel, or unlike attract, like repel. Unlike charges attract, like charges repel. But these are attracting. So this is what the field line looks like. We'll have a straight line like this first, and we'll have one line going like this, one line going like this. We'll have another line which goes like this. Another line which goes like this. Another line which, second, that's about it. Let's make it a bit small. We don't have to make it this big.
Sir, should we draw this?
Yes, you have to. The field line patterns are positive to negative. It's always going positive to negative. Anyone, any questions? Najla, Safa,
No, no, sir.
Sir, can you do? I just want to take screenshot and then I'll write it afterwards.
Okay. Safa, कौन सा चाहिए? Which one?
The negative one.
Okay, look at it. Keep writing right now, right? Finish right now. Now these are the fundamentals. We need to be clear about the fundamentals so we can easily know what else is happening. Just a second. If you're doing it with a pencil, I want you to do it with a pencil, obviously. You should realize there's something that would actually look like this. What a big difference. If you're doing it with a pen, please make all diagrams with a pencil.
I did it with a pen.
Pen, then leave it as it is. But what we need to know is the field lines are actually getting farther apart, or they are becoming far apart. What you'll realize is, just a second, let's add one more line right here. Let's say, so it's basically lines are from everywhere and they're going towards negative. That's what we get. Something like this. So there's a curve happening. But what we need to realize is the distance is increasing. Look, this distance is, as I go outwards, the distance increases. And inside it becomes closer and closer and closer. Okay? Since the outer I go, the more far apart it becomes. You don't have to draw the D. Don't draw that. So what we realize is a few things right here. Field lines bend and from positive to negative. Let's say direction positive to negative.
Sir, this is the third one.
Third one, yes. Third one, let's write the name. Third one is called, write the name before writing it. This is basically like charge, unlike charges. These are called unlike charges. So field lines bend direction from bend and the direction is from positive to negative. And unlike charges right over here, they attract. So one more thing we need to write is field lines get farther apart away from charges.
Sir, why they are called like unlike charges?
I'll tell you why. Because look, I have one negative, one positive. So they're not same. They're not like. Like means being like each other, right? This is like him, you're like her, something like this. But these are not like each other. They are different. So these are called unlike charges. And if you have positive, negative, they're going to attract always. Is that clear?
Yes, sir.
Finished?
Yes, sir.
Everyone?
Yes, sir.
Okay.
So now
So one
I
thing you
have
should realize. All right, Safa, keep writing. The next one is right here. This one, which we have is called like charges. Fourth one. So again, I'll have to get a positive charge. Well, I need to have charges which are similar. Okay. So if I take positive and positive, two of the positive charges, and keep them together like this, what will happen is the field lines will look something like this. They will go up from here. That is what they look like. Now that looks kind. What does that look like? All that's happening is the field lines are not joining ever. They are separate from each other.
That means they don't attract each other.
No, they repel. They're pushing each other away, right? And the field lines are always for positive, they're outwards. This is what they look like. They are pushing each other. They don't want to be together. They're like, we don't want to be together, we hate you. So they're going away.
Do we draw this too?
Yes, you have to. One main feature is look, this one, the line in the middle. So first we'll come downwards and bend towards it. And bend towards it. These lines are not joining and they're going up like this, which is the main thing. Like charges repel. Now if you add positive, positive, negative, negative, it would look the same as well. In the exam, you have to show these, especially, and yeah, you have to show the whole thing. Yep. In this, you don't have to show as many. You need to show at least 4 or 5 feed lines. Right now, we have 1, 2, or let's say 5 feed lines on each charge. This is 1, 2, 3, 4, 5. So you need to show 5. But I would prefer that you show the whole thing to get full marks. Now finish writing this, drawing it, tell me when you're done. Use a pencil, by the way. Safa, are you writing?
so I'm drawing the fourth one.
The fourth one. Now we have one more thing happening here, which is the fifth one. What? Yes, we do have another one. And you'll love to see it. It's much simpler than all of these. This is the one which I had hidden away before, this one. Ta-da, this is the one, right? And it's actually much simpler. All you need is two plates. Now this is called a plate. What is that? This is a positive plate. And this is a negative plate. These are called plates, basically, not just plates. Or charged plates, charged metal plates.
Sir, I have
One thing we need to
actually
do here.
I have actually
Yes.
drawn this at the start when you first showed it, before doing point 3 and 4.
So I want you to draw it one more time as 0.5. Okay, and cut that one. If you have drawn it somewhere, then just write 0.5 over there like this. Don't
I have
cut
drawn
it.
it on the same page, but it's at the top. And then there's
Never-
point 3 and 4.
Yeah, doesn't make a difference, right? Just on the top, write 0.5 then. And a few things you need to know is field lines are straight and another thing you need to know is field lines are equidistant. Let's write it like this. Field lines are straight and equidistant. What is the meaning of equidistant? Mavadda?
Not very far.
No. Equidistant means
They're equal in distance. Like
same distance, equal in distance.
this.
Same distance. And straight means straight, right? Yeah. That tells us everything. There's one more actually. What? All right. Yes, we do have one more, which is sixth one. Now, I'm giving you all of these as let's say in one place you can know and you can memorize and revise later, right? Because in the book it's all over the place. Last one we have is keep writing. If you can't see something, tell me. I'll go back to it. Rana, Najla, are you writing?
Yes, sir.
Yes, sir.
Good. Now we have spikes. What are these? Now those cool spikes.
The ones that come with the sharp edges.
Sharp edges, yes. Just a second. No, not these spikes, by the way. We're not talking about that. Okay. But what we are talking about is this. Just a second, just a second. We are talking about these spikes. Can you see that? It's like a pin. Not that spike either. This one, same one, but the I'll show it to you actually. This is what a spike means. Fine, that's a spike right there. Now our job is to draw the electric field lines from here. Well, what does this mean? If all of these are positive, there's a lot of positive charge here. What will it look like? Let's see, just a second. Field lines will look like this. something like this and something like this on both the sides. You'll realize something is happening. As I go far and far away, the field lines are much and much more weak. Look the distance. We look at something called electric field strength in a second. So the distance increases. You need to know that. Let's make this even farther away. This much. So the closer I go to the sharp peak, the sharp spike, the more close the field lines become. And we'll see what happens in a second. Instead of making it positive, actually, let's make it negative. And what we realize is, because this spike is so sharp, what happens is electrons fly away from here. They leave into the, they basically go out. Let's just say they go out. Charge, let's say this is called charge, or let's say ions escape. Let's say ions escape, cause spikes. Now this is what you have to make. Quickly make it, and on the top right, ions escape. If you have a different color, use the pen to draw the ions escaping. Now these are ions escaping. That's not the field line. The field lines are like this, always positive to negative. Make the direction as well. So from positive to negative, so towards negative. Let's write over here. So the properties are.
Sir, I don't
Yes?
understand this.
I'll explain this later. But we'll explain this as well. Right now, you just have to draw it, right? We'll talk about this. What is happening and what this means. Electric field lines. Strongest at sharp edge to because closest together. Next thing is ions escape. Now, Najla, tell me how much have you finished writing?
I'm actually writing the second point.
Okay. Safa?
So I just want to write the point and draw the diagram of 0.5. Now I'm writing.
Okay. Have you drawn 5?
No.
So draw 5. Can you see it?
Yes, sir.
All right. If you want me to zoom in, I can. Now, next thing is, Next one is Mawadda. Have you finished?
Yes.
Have you finished everything? Sure?
Yes.
Perfect. Dula,
Done, sir.
Rana,
Yes, sir, I'm done.
done? Then who's
Yes.
remaining? Diana,
I finished.
finished. Now, Safa, take your time.
Okay, done, sir.
Okay.
Sir.
Done? All right, good. Now we'll just talk about how spikes and everything work. We'll look at that in a second. Before you do, okay, we'll look at that. Okay. Let's see. Okay. Safa, have you finished?
Yes, I finished 5. Now I have to do 6.
You can do 6. Now the rest of you first, Diana, start reading from here. Electric field lines are
Electric field lines are the number 1, strongest at sharp edge because closest together. Number 2, ions escape from sharp edge causing ionization of air. Number 3, sparks can occur at edge point.
not edge point, sorry. Just a second. Change this to edge. Instead of edge point, right? Sharp edge. Just change this one right here, sharp edge. Now, what we realize here is that electric field lines are strongest at the sharp edge. Why is that? Because they are closest together. As in they're close together, the more close the field lines are, the stronger the field lines are. Is that clear? The more close the field lines are, what are they? The more close they are, the stronger they are. Say it after me. Mawadda,
Yes.
say it with me, all right? Say it after me. The more close the field lines are, the stronger they are.
The more close the field lines are, the sharper they are.
Not sharper, the stronger. All
Stronger.
right, let's see. Safa, have you finished?
Sir, I'm drawing it.
All right,
Sir,
right.
if you
Now,
want to
okay,
write after
it's okay,
this.
it's okay. Look. Now, what's happening here is, now Najla, talk to me. Read the second point one more time.
Ions escape from sharp edge, causing ionization of air.
All right, what does that mean? Well, we have this point right here. But if you look at this sharp edge, the fields are so close together. Look, right here, they're far apart. They're not that close. But as we go closer to the sharp edge, this point right here, this one, the closer the field lines become. And at this point right here, at this point, what happens is that electrons, the field lines are so strong that electrons are basically, they go out of air. Okay. Or what they cause is, look, if I have some particle here of air, let's have some particle of air. Some particle of air which looks like this. This is air molecule. Let's say air. So all of these air molecules have protons and electrons in them, right? Everything has protons and electrons. Now, what this guy does is, what the negative charge is here, the field is, by the way, negative. So what they do is, they're so strong that they pull all the electrons. What they do is, they basically pull all the positive particles together towards them. So if all the positive part of the atom, let's say atom have both positive and negative parts, positive and negative, they're neutral. All of these are neutral in air. But since this is so strong, the negative particles are so, the field is so strong, they're going to pull all these positive particles outside towards this. And what are we left with then? If all the positive charges go to this point right here, because over here we have negative charges, right? They're very strong. So they pull all the positive charges towards over here. And what is left? At the end, only these negative particles are left. So what is happening is that the air, which was neutral, is becoming ions. What is happening is ions escape from sharp edge, causing ionization of the air. What basically happens is the ions, no, it's actually just a second. I want you to change this word in the notes, right? Step right ions, right charge. Charge escapes from sharp edge. Please change it and tell me when you're done. Now the electric field is so strong that the charge can actually escape outside of that point. And what that does is it makes air into ions, into positive and negative ions. And that is what we see as spark. I'll show it to you. If you see this right here, that is what we see at this point right here, at this sharp edge. We see the spark. That is what happens. Spark can occur at the sharp edge because the air itself becomes ions. Just one thing. Ask me questions, guys. Come on, Lula, ask me a question about this.
I currently don't have any question, but if I find any, I'll ask.
Then Mavata, ask a question. Now, whoever asks a logical and a good question, they'll get 2 points. Ask anything
About this thing.
about this thing, spikes and the spark and everything. 0.6. And it doesn't matter if you understand or not. It's like question me, like interrogate me, right? Imagine you're a police officer and you're interrogating me about physics. Start. Any questions, Diana?
Okay.
Does the sparks cause because of the ionization of air?
I swear that's
Exactly,
my
yes.
question.
Oh my god.
That was the question. See, so you guys have similar questions. That's amazing. So what happens here is that because of this strong electric field, because look, the electric fields become even stronger here. As you get closer, they become very, very, very strong, and so strong at this sharp point that look how far are they here, and at this sharp point they're literally next to each other. What that causes is air becomes ions. Why does it become ions? Because the electric field is so strong that the electrons and everything are pulled from the air itself. And what that does is it causes sparks. Those charges that escape from the surface, we see that as spark right here. Any questions? Now I hope that's clear. Ask me.
Do spikes increase friction like the shoes the runners use for sports?
Yeah, they do increase. They don't increase. Okay, friction. Okay, yeah, they do increase friction. Yes. but that's irrelevant to this point. That is in pressure, chapter number 5. Okay, so that's what we have here. So 6 kinds of electric fields are done. Just a second, let's make it smaller. Now the next thing we're looking at is called current. What are we looking at?
Current.
Current. Let's see. I'll open the book for you. Can you see the book?
Yes, sir.
Yeah, look right here. Safa, read this point. From here. First one, this.
Very strong electric field analyzes air. Charge leaks away from this point.
So what happens is, since the field lines become close and close to the sharp point, that sharp point can cause sparks because the field is very strong. Now, okay. Next, current. Najla, start from here, read.
Okay. An electric cell, commonly called a battery, can make electrons move, but only if there is a conductor connecting its two terminals. Then chemical reaction inside a cell pushing electrons from the negative terminal round to the positive terminal.
Now, to make it very easy to you, let's hurry up. Let's just go here, Karan, and I'll show you what we need to know in this. Right? The first thing we need to know is that what is current? Current, just write the definitions first. Yep, write the definition for current. Current is flow of charge. What is current?
It's a flow of charge.
Flow of charge. Unit is amperes. Amperes, which is A. Okay, that's current. The next thing we have to look at is, we know what current is now, but well, where is a current? Current is usually in a circuit. So I'll make a circuit for you. This is a rectangle, and from this we'll make a circuit. We'll put that area there. We'll put some here. Okay, look. Now, first thing first, this is called a bulb. This is the symbol for bulb. This is the symbol for a switch. And this is the symbol for a battery. Okay, how do I know all of this? Well, you'll have to memorize it. This is bulb. This is switch. Start writing in your notebook quick. And this is called a cell. Instead of writing a cell, let's make a battery. But that was a cell. But this, if I have more of these, it's called a battery. That's a cell. If I have more of these, that's called a battery. Now what happens is, please write over here the flow of current below. Direction of flow of current.
Sir, we should also draw this.
Yes, you should. Direction of flow of current. Right? Instead of writing this, just write conventional current direction. Then we write electron direction. And underline these two things: current direction, electron direction. Now what we laid in this is that direction of current is always positive to negative. Flow of electron is always negative to positive. If I draw it for you, always another thing, let's make a cell right here. This is a cell. Cell has the biggest side is always positive, the smaller side is always negative. Bigger is positive, smaller is negative. So since I know that the current direction is positive to negative, this is what the current direction looks like. If I close the switch, let's close the switch now. The switch is closed. First it was on, or it was off. If I don't connect it, the circuit is incomplete. For the circuit to, for the bulb to turn on, I must close the switch like this. If I close the switch, what will happen is electrons will start flowing from positive side. The current will start flowing from positive to negative, like this. But the opposite happens for the electron direction. The electron direction goes from negative to positive. This is current, and this is electron. Tell me when you're done writing. Just a second. In the first one, please add one more thing, which is current is rate of flow of charge. Add the word rate of flow. Mawadda, what are you writing right now?
I finished drawing and writing.
Everything?
Yes.
Mawadda is done. Safa,
Sir, I'm done.
that's amazing. Diana, Luna,
I'm done.
Najla, Rana,
I'm done.
Rana, have you finished?
Yes, I finished now.
All right. Now, first thing first, Rana, what are we seeing here? We are seeing that electrons go from negative to positive. It's opposite. So let's write over here. We'll just write it here once. One more line right here. Electrons flow opposite, or let's just say current flows opposite to electrons. Now you'll ask, why is that? If current is the flow of charge and electrons are charged, right? Electrons are what give charge. So why is it opposite? Because look, current was discovered before we knew electrons had existed. We found current before we knew that electrons are something or are existing. So we just said, okay, it's positive, negative. Now afterwards, in 1990s, we found something electron. We found this guy, and we realized that it's actually flowing from negative to positive. But since we had made physics, we had already made so much of physics with this conventional direction, so we still say positive to negative, even though electron flows negative to positive. So in the exam, if they ask you what way is the current flowing, you'll always say positive to negative. Where is the electron flowing? Negative to positive. And current is opposite to electrons. Next, opposite to
Sir, can you
Next,
explain
yeah.
the conventional flow of current direction again?
Okay, I'll say it one more time. No worries. So if anyone wants me to explain it, please ask me at least two or three times. It's okay because we have time. Now, conventional flow basically means conventional is what means is, let's say, accepted, okay, or standard. It's something we all use. Everyone uses this. So it also means what everyone says or what everyone uses. Now they will not ask you this. They won't ask you what conventional means or what is conventional. They won't ask any of this. They just ask you where is the flow of electron. You will say where is the flow of current. So you'll say current is positive to negative always. So if I have, let's say, another cell, let's take an example actually right here. If I make an example 1, this is my circuit like this, and I have a battery right here and a bulb right here. And I have another point. Let's say this point is called A, and this point is called B. Now your job is to tell me in which direction is current flowing. The options are: first option is AB, the second option is BA. I'm asking what is the current direction?
Can I answer?
Let's ask everyone privately.
Okay.
Okay.
We have a bulb. This is a bulb, we know that. And this is my cell. Now, Safa, I want you to work with me. Read the question,
Yes.
Safa.
What
This
is the
one.
current direction?
What is the current direction? I have the bulb, I have the cell. Firstly, Safa, tell me which terminal is positive? The bigger one or the smaller one? Which is positive? The bigger one or the smaller?
Bigger one.
Bigger is positive, smaller is negative. Fine. And from here, read the conventional flow of read the current direction. What is it?
From positive to negative.
So it will go like this. Positive to negative. By the way, did I just hear a cat somewhere?
Sir, it's my.
That's I love cats. That's cute. Okay. Mashallah. Let's continue. Let's continue. So we have this is the current direction. Fine. Now, how are we going? Are we going A to B or B to A?
A to B.
So A to B. So therefore the correct answer is A to B. Now I've only gotten 2 answers. Well, where are the other ones? Diana,
Yes, sir.
solve the next question, all of you. If you don't give any answer from these, then you're going out of class. Question is, where is the electron direction? Electron flow direction. I need the answer from Najla. I need the answer from Rana. I need the answer from Diana, Safa.
Negative to positive.
I don't know. Write it in the chat. Maybe it's AB, maybe it's BA. You only have 2 options. You have AB or BA. This is the option. I've gotten 4 answers. So 2 people are remaining, Safa and Rana. Safa is here, okay. Rana, what is the flow of electron direction? Now, Rana, I want you to work with me on this one.
Yes.
Read the questions, Rana.
Is for follow direction.
Right, flow of direction, electron flow direction. Now, E minus, we said it correctly, but E minus, we don't say E minus, we say electron. What do we say?
Oh, electron. Okay.
So the question is electron flow direction. Or
Mhm.
let's just put this like this, flow of electron direction. So how is the electron flowing? Is it flowing from which side? So we'll read the answer first. We'll read the points first, which I've given you. Rana, read this part.
Which
This one.
follow of reaction, the direction of negative to
Positive.
positive.
So
Yeah.
where is it? It's from negative to? What is the direction? Always negative to positive.
Yeah.
Fine. So if I go negative to positive, the smaller terminal, this one, if you look over here, which is big? This guy is big or is this guy big? Right or left? This one? So the right one is the bigger one, right? So the smaller one is going to be negative. Is that clear?
Yes.
Now smaller
Yes.
one is negative, fine, we know that. The next thing is from here to here, it's always negative to positive, like this. So always like this, negative to positive. So it's going from negative to positive, like this, like this, like this. So Diana, can you tell me, is it BA or AB? Is it going
BA.
from BA? So the correct answer over here is BA. Rana, do you understand? Since it's negative to positive, we're going from B to A. Look, we're going from B to A, like this. So the answer is BA.
Yeah.
Rana, any questions?
Yeah.
Should I explain one more time? Any questions?
No, I understand.
All right. The next one. I'll just give it to you one last time for everyone. Everyone should give me the correct answer. Now you'll not get any help this time. Now all we have is we have a bulb. What is the electron flow direction? Is it K to F or F to K? Answer in the chat.
So what's the question again?
The question is, what is the direction of current?
The direction of what?
Of current.
Current.
But how do we know where the positive and negative are?
Yeah.
So will this circuit have a current? The
No,
circuit
it
has
won't
no
because
current.
there's no positive and negative.
Yeah, there's well, not positive, negative. There's no battery. There's no power supply. There's no cell.
There's no cell.
No cell. So that was a trick question.
There's no.
Now
Yeah.
let's add one cell right here. Instead of adding a cell, I'll add a battery. Battery is basically multiple cells. What is a battery? Multiple cells. Write this in your notebook. They may ask this in the exam. Battery is multiple cells. Let's just say, yeah, multiple cells. So what is the direction? KF or FK? In the chart. The first one to answer
This
gets
for
2 points.
currents, yeah. Is it the direction for currents or electron?
It's written here. It is direction for current.
Sir, should we say like from positive to negative or something like that?
Now you have to say, is it K to F? So is it like this or is it like this?
Okay.
K to F or F to K? I've gotten 2 answers. Najla and Mawadda. I've gotten Lula. I've gotten Safa. Go ahead, Diana. Rana, what do you think?
Um,
Let's first think about this. Which is the positive side? The bigger one is positive, smaller is negative. And what is the direction of current, Rana? It is always positive to
negative.
negative. So my direction is going from K, it's going like this, from K to F, isn't it? Is it going
Yes.
F to K or K to F? Tell me.
Is K to F?
K to F, because it's going like this, not in the opposite direction, not like that, like this. So it's going K to F. So the correct answer should be K to F. So I need Mavadda and Diana to speak to me. Mavadda,
Yes. Yes, sir.
now what is the correct answer?
It's KF.
KF. Why did you write FK? Any questions? Doubts?
No, sir. It's clear for me now.
Diana?
Same.
Clear? All right. Positive to negative, not negative to positive. In the same way, if I ask you what is the direction of the electrons? What is the direction of electrons? In the chart, So there's a competition happening. It's not just you're not just getting. I'm noting down the points here. Whoever gives the answer first wins. Now, Diana, again, yes, it's for the not the current, it's for the electrons. Yeah, that's the direction of electrons.
Direction
Yes.
of electrons.
Yes, electrons. So KF or FK? I'm just writing the points here. So there's Diana, there's Lula, there's Safa, there's Najla, there's Rana, and there's Mavadda. Diana has 1 point. Lula has 2 points. Safa has 2 points. Najla has 3 points. Rana has 1 point. Mavadda has 2 points. The Najla is answering first. So I think Najla is understanding, right, Najla?
Yes, sir.
That's good. All right. Now for this one, Mavadda answered first. So she got 2 points. Diana, answer quick. Yes, Diana?
That was my mistake.
It's okay. Any doubts? What is the answer? Say it to me. How would you read this part, Diana? The last line. Current flow is
The current flow is opposite direction of electrons.
it is opposite direction of electrons. So if current flow is K, what will electrons be? It will be negative to positive like this. It will be FK.
Okay.
It's opposite. So if this was KF, current is KF, then electron is FK. Negative to positive, the other way around. Now, last thing I'll give you is a few equations to finish. Now, write this as well. One more point. Current flows part of. I should remove that part. Let's do this. Equation for current. Current is C. No, current is current, which is equals to charge, which is divided by time. Since we know current is flow or rate of flow of electrons, rate of flow of charge. Since we realize it's rate of flow of charge, the equation is current is equals to time, charge over time. What that means is how much current is flowing per unit time. The equation for this is going to be, just a second, is going to be current is charge over time, and I know that current is A, amperes, charge is coulombs, which is C, and time is seconds. Let's give an example actually. Now write the unit here. Unit is unit of current is either amperes A, or it is charge coulomb per second. Write this, tell me when you're done. Look at example 1.
Sir, what does the A or coulomb per second mean?
Well, A, okay, I'll tell you then. Write this. Well, the unit for charge is coulomb. The unit for time is second. The unit for current is amperes. So what we realize is the unit is either amperes, which is equals to coulomb per second. Okay, so what that means is, let's look at an example. Okay, let's look at an example. If I tell you charge is, I had 5 coulombs of charge, and the time it takes is, let's say, instead of saying 5, let's say 10. Easy. It takes 2 seconds to flow. Charge, this much charge is flowing in 2 seconds. Can you find what is current? Diana, work with me. What is current? How much will current be? To find current, I'll have to see that current is now check if you've written everything exactly the same. And then start
We
writing
have
the
tried
first
also the
example.
example.
Say that again.
We have tried the example too.
Yes, you have to write the example. So current is charge over time, I know that. But what is the charge? Charge is given as 10 coulomb. And how much is time?
2
Safa?
seconds.
Okay, 2 seconds. So Najla, what is the charge? What is the current then?
5.
5 coulomb per second. How much? 5 coulomb per second. Because I have coulomb divided by second. But I can also say is equals to 5 amperes. Is that clear? Any questions?
No, sir.
No, sir.
I'll give
No,
you some questions to do on your own. Now, Rana, I want you to do the next question with me. Like one.
Yes.
Finish writing this in your notebook. All you have to do is use the formula, right? Current is charge over time. Now, next one. Example 2. If I say charge is 20 coulombs and time is 4 seconds. Rana, what is the equation for current? Read over this one. Current is equals to
is equal charge time.
charge divided by time. Or charge,
Yeah.
what is it? Charge divided by time. Say it one more time.
Current charge divided by time.
So current is charge divided by time. Perfect.
Sir,
Now,
should
how do
we
we
send
solve
the
it?
answer in the chat?
Yeah, write the answer in the chat, everyone, and also do it on your notebook. Now charge is this much, time is this much. What is the current? Now Rana, that I know that current is charge over time, right? So Yalla, tell me, how do I solve this?
Yeah.
It's going to be charge over
Um,
time. And what is the charge given in the question?
this charge is 20.
20. What is the
Yeah.
C? What does that mean? What is the C?
Recount
Coulomb. Coulomb. What is it?
Coulomb.
Coulomb. So whenever we write charge, we write Coulomb after it. There's 20 coulombs. What is the time given?
Yeah. 4
Time is
seconds.
4 seconds.
Time is
So
4,
charge will
4
be,
seconds.
so charge is 20 coulomb. And how much was time?
4 seconds.
So give me the answer.
Okay.
I've gotten
Answer is
Lula,
5.
Mohammed, 5. How 5 what? What is after 5? We say 5 amperes. What do we say?
5 is
Ampere.
ampere.
Yes, 5 ampere. So current is always
Okay.
in ampere.
Okay.
Charge is always in coulomb.
Coulomb.
Is that clear?
Yes.
Understood?
Yeah, I
Okay, so
understand.
I've got, all right, everyone got the answer correct. Good job. Now that's easy. Everyone can do. We know this now. Now it's easy. Not before, but now it is. Hopefully. Now next thing we have to do is example number 3, which we'll look at is we have charge. Okay. I don't know what charge is, and I have given current, and you have time. Time is 10 seconds. Your job is to find the charge. Do it, write the answer in the chat. Now, everyone has open their mics, and I want a group of 2 actually. So, Rana and Lula, you're a team. Say yes,
Okay.
sir.
Yes, sir.
Lula,
Yes, sir.
so Lula and Rana are a team. How do we solve this question? I need Rana to give the answer, and so solve it and tell me.
Okay.
Now, Lula and Rana have to work together. You can talk if you want to. And Diana and Mawadda and Najla and Safa, I'll make 2 groups again. Mawadda and Diana are a group. Najla and Safa are a group. Is that clear?
Yeah.
Now the other people don't say anything right now. Just give the answer in the chat. Okay, one of you has to give the answer. And Lula and Rana, you have to talk and then give the answer. Now from the teams, only Safa can answer, only Diana can answer, and only Rana can answer. Privately.
Okay.
So now it's up to you how you explain it to your friend or how you guys answer. Start. You have 2 minutes for this. My mic is off. You guys can talk. By the way, if the time runs out and I don't get an answer, the team is disqualified. The last team remaining is the winner.
Sir, do we all have to talk?
You can. It's your choice, right? You can talk. No worries. You can talk in the chat. You can talk with the mic on. It's fine.
Okay, sir, I already sent our answer.
Now you can't send the answer. That's the thing. Diana has to send it. The people who are sending is Diana, Rana, and Safa.
What if we know the answer?
Okay. So when you give the answer, you'll also have to explain it. So Diana, Rana, and Safa will also have to explain it. So you can take the mic if you want to talk, because if you give the correct answer and you can't explain it, then you don't get any marks. Start.
Now, who have to give the answer and who have to explain?
Okay, so the one who gives the answer has to explain. Najla and Safar are a team. Dula and Rana are a team. And Diana and Mawadda are a team. So Diana, these guys have to give answer and explain.
Okay.
But actually, these guys have to give answer. Let's say Lula, Najla, Mawadda give answer, and Diana, Rana, Safa have to explain. Is that better? Okay. Now, if you give correct answer and your teammate cannot explain, then you get 0 points. The time has started.
So can it be the opposite?
No. That's the whole point, right? It cannot be the opposite. So you can talk if you want. It's totally fine.
Okay, sir, I gave you the answer.
Me too.
Okay. So Najla has given the answer. Okay. Lula has given the answer. Mawadda, I haven't gotten your answer.
Sir, I sent the first. Sir, I sent the answer.
Okay, so Diana has sent the answer. Fine. Okay. And Mawadda also has sent the answer. Fine. Okay. Now, okay. Now for the first one, Mawadda and Diana, it's team A part. Your turn. Let's start with that. Diana, explain how you got the answer.
So our answer is 200C. That's because we
Okay.
divide time with the current
Okay.
to get the
Divided
charge.
time with current. Get the charge. Divided time with current. So anything else you want to say?
No.
Okay. Rana, explain what is your answer and your team's answer and how did you get it? Rana and Lula, talk together, both of you.
Sir,
Explain.
I have actually made a mistake typing it.
Okay, it's fine. It's fine. So say your answer. Say to me.
It's 200C.
Okay. And how did you get it? Rana, explain.
So
Now, Lula, you can tell Rana and she can tell me. That also works.
أنا أريد إنه إحنا ضربناها 10 وال20 ضربناها سوا.
لولا عيد الكلام ما
10 وال20 ضربناها سوا عشان تجيب لنا التشارج.
So we divide for charge and time.
Okay.
So
Then. Now just give me the equation. Now I want the equation from Rana. What is the equation of it?
ضربناه ما قسمناه.
Multiply.
يعني نقول العكس.
ايوه احنا ضربناه انت قلتي قسمناه.
Oh. طيب.
Okay. Yes.
So we are
Let's
divide charge and time and we
so divide charge and time. Fine. Current is
Yeah.
charge divided time. Okay. Then what? Then Lula Rana, your time is running out.
أنا شوفي هو قال divide، أنا قاعد أقول لك multiply، إحنا ضربناه ضرب.
Yeah. يعني أقول إنه divide.
لا العكس.
إيش اللي عكس؟
أنت قلتي لي سوي divide، أنا قاعد أقول لك سوي multiply.
So we divide charge and time, and we come 200.
لا أنا قولي له we multiplied.
We
yeah.
multiply.
Okay. Multiply current with time. Okay. So look, Rana, we take this time. Okay, it's being divided on this side. We divide it, but after that, afterwards, we multiply time with current. Okay, to get
Yeah, current divide to time.
yeah. So current multiply with time to get charge. Okay.
Yeah.
And therefore your answer is 200. I don't know if it's correct or not. Fine. Okay. Now Najla Safa. Najla, what is the answer? You got Team
200
C,
C.
Najla? 200 C. Safa, explain.
So we knew the current and time. We didn't knew the charge, so we multiply current and time, which is current is 20A into 10 seconds, which we get 200 C.
200 C. All right. So that's perfect. So what we do is current was charge by time. So charge is current into time. Therefore, current was 20 into 10, which will give us 200. That's the answer. Fine. Now, that's fine. So I'll give the points here. The points are Mavadda Diana, you will get 10. Lula Rana will get 10. Najla Safa get 15. Because your answer was more clear to understand. Right? Now, that concludes our class here. That makes Team C the winner. And there's a draw between these guys. Actually, before we conclude, I'll ask one more question, only from Team A and Team B. The question is, what is the direction of current? You can't say it. I want the answer in the chat and this explanation, or actually before, what is the direction of flow of electron? The answer in the chat. The answer in the chat, Rana and Diana have to explain. Mavadda, Lula, give the answer, quick. First, let's say, yeah, go on, give the answer in the chat. The direction of electron. Okay. Direction of electron. Direction of electron. Direction of electron. Now, Safa, Najla, you can also give the answer.
Okay, sir.
Separately. So you already won. You won the competition. We'll have another competition in the next part. Now, so we have okay. I've gotten the answer. Now, Diana, explain what is the direction of the electrons and how do you find it?
It's negative to positive.
Okay, but why? Or compared to electron current, how do you find it compared to current?
It's the opposite of the current.
Okay, let me think about that. Okay, Lula, Rana, Lula, what is the answer?
It's it flows from the negative to positive.
So I've gotten the answer, negative to positive from both. Okay, Rana, why is it negative to positive?
Negative to positive.
Yes, but why? Or how do we find electron direction from current direction? So Lula and Rana discuss quick, you don't have time.
Sir, the question is direction of electrons or
Electron.
oh, sorry. Okay.
Sir,
And
are
the
we wrong?
question, yeah. Now I don't know the answer. I'll tell you. First, let Lula and Rana answer. Rana, Lula, quick, discuss. How can I compare electron direction with the direction of current? How can I compare electron direction with direction of current? Now, if time runs out, then I'll have to give the answer. Now, the other people, team A, I want you to start counting till 15. Start.
I sent you the answer, sir.
All right.
Yeah,
Diana. Mavata, Diana, count till 15. Quick.
Anna.
15, 14, 13, 12,
Yes.
11,
قولي
10,
لي إن الدايركشن حق
eight,
الماينس
7, 6,
رايح بالعكس يعني
5,
الدايركشن حق
4,
الكرنت is opposite to the
3,
direction of electrons.
2,
Electron
1.
is the opposite.
Time is done. Rana, what is the answer? How is it compared to the current direction? Then?
Because this what? Because it's opposite
Opposite to what? Of
to direction of electrons. Or they wait.
so current is opposite to direction of all right. Now the answer is correct, but I'm not sure if you know it. One last try. How is the current direction compared with the electron direction? Is it same or opposite?
It is it's opposite.
Opposite, all right. So, but you did get the correct answer. But the thing is, Mavadda Diana win by 1 point because they got it quicker. Not completely. This is 14. These guys 13. So we have the team right here. Winner, second place, and little below second place, and that's it.
Sir, why not completely?
Because they did give the correct answer, right? The point is that everyone understands what's happening. It's easy to give the correct answer, but the whole point is that everyone understands. I don't want one of you to get full A stars and everyone else to get D's and C's. That's the whole point. So that concludes our class today. Now, I hope everyone understood what we did. Lula, recap, what did we study?
Today we studied about current and voltage, and we learned about charge, mass, electric field, and force, gravitational field, and we learned about the electric field patterns. We learned about all the 6 rules and points. And then we did a equation for currents with examples.
Examples. Now, in the next class, we're going to learn about measurement of current and voltage and resistance. That's all for now. I hope you understood what you studied, and I hope you learned something. That's all. Take care. Goodbye. Masalama.
Bye.